Okay, on number 19, they're mixing the idea of probability with imaginary numbers and the values of imaginary numbers when they're raised to different powers. If A is randomly chosen from the numbers 20 through 30 inclusive. Okay, so what I'm going to do first is just jot down 20 through 30 inclusive so that we can think through this. 4, 25, 26, 27, 28, 29, and 30. Okay, so what is the probability that the value of the expression is 1 or negative 1? So essentially what we're saying here is, what if I is raised to the 20th power, if I is raised to the 21st power, and so on. So that's what we're talking about, I to the 20th, I to the 21st, etc. So make sure you understand that. And I copied this powers of I section from lesson 69. There's a lot of information back there. There's another table back on lesson 69 that may be helpful for you as well. But what I wanted you to see is this pattern here. I to the first power gives you I. To the second power is -1. Then we have negative I and then 1. Keep going. We end up with I to the fifth. We end up with I again, -1, negative I, and 1. And that pattern just continues to repeat itself. So, and it repeats itself every four numbers, okay? So think about 20. 20 is divisible by 4. So the value, if I would be raised to the 20th power, then you would end up with a 1, okay? It would just equal 1, okay? See this? Because it's I to the 4th. 20 divided by 4 is going to be the same as 1. Okay, so this value is going to be 1. All right, then if you go to the next, if you go to 21, that's going to be I. Okay, well then the next one after that is -1. I raised to the 22nd power is -1, and then to the 23rd power is going to be -I. So you see we've got this pattern going on now. We have a 1, and then we have I, and then we have, for 26, we have -1, and then for 27, -I. The pattern is just repeating itself. 28, we have 1, and I, and then we end up with -1. Okay, so now we have the information to help us evaluate the probability that our expression is going to be either 1 or -1. First of all, we need to know how many numbers we have altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like we have 11, so that's going to be our denominator. And then how many ones or -1s do we have? Well, we have 1, 2, 3, 4, 5, 6. So, if I'm not mistaken, we have the probability of getting an expression when you raise I to the one of these powers of 6/11ths.